Hello, and welcome to Tech Talk with ER. I'm your host, Paul Jackson. I'm one of the application engineers here at ElectroRent, and myself and my fellow colleagues are debuting this new series here where we'll be discussing various test and measurement equipment solutions, test methodology ideas for your application, and of course the latest technology trends that are happening in the industries today. Did you know that ElectroRent is the exclusive rental partner of NI equipment, such as the NI PXI modular chassis and the VST module, which we'll be discussing today? Let's dive in and check it out. The NI PXI modular system is excellent for when speed and accuracy are needed together. As you can see here in the NI chassis that I have on display here, I opened up and you can see within here, the system is comprised of various modules that fit inside this chassis housing. For example, we're showing the NI PXI 1078D series chassis. As you see here in the beginning of the chassis, in the first slot, can house the NI integrated PC controller, where you will have all your software installed and can do all your testing from there. In this system, we also have the pattern generator, the SMU, and today's feature product, the vector signal transceiver, also known as the VST. In this testing today, I have connected both the input and output together via this blue jumper cable here.
The PXI vector signal transceiver, or VST, combines a vector signal analyzer and vector signal generator with a user-programmable FPGA and high-speed serial and parallel digital interfaces for real-time signal processing and control. With up to 1 GHz of instantaneous RF or complex bandwidth, the NI VST is ideally suited for a wide range of applications such as RFIC validation, production testing, radar prototyping, and other various RF wideband test scenarios. The unit we are testing here today, demonstrating, is the PXIe 5644, which is a 6 GHz VST. VSTs can now be had all the way up to 44 GHz, which is ideally suited for 5G, FR1, and FR2 testing. On here, you'll see I have here showing the RFSA soft front panel, which is their simulated spectrum analyzer, and the RFSG soft front panel, which is their vector signal generator. As you can tell, the analyzer and generator come with a traditional looking screen, buttons, and knobs to control everything as you would with a traditional compared to such as a traditional spectrum analyzer and signal generator. In this case, we're using 2.4 gigahertz signal frequency. It'll be in CW, and just simply turn on the RF, and we can go to the spectrum analyzer and see the signal here. From here, you can add various markers, do a peak search, and see here your display of what you have here. Span, amplitude, and bandwidth can also be adjusted here, as well as the trace. If you wish to do a max hold, just simply do that, and you can achieve a max hold readout. Do average or clear write data. If you wish to add a modulation, for example, you could go here to Mode, ARB, and either load an IQ file, which can be in a TDMS file or a text file if you have as well. We'll go here, load a TDMS file of a standard LTE uplinked FDD signal, QPSK modulation at 10 megahertz. To simply load, you can name your waveform name however you wish to name it, hit OK, and then go back and turn on the RF, and we can go to our spectrum analyzer soft front panel, and as you see here, you have a 10 megahertz LTE signal already on display. Max hold to show you a cleaner signal. We'll go back to clear write. You can also have various types of measurements. If you wish to measure the channel power, you can have the channel power measurement set there and adjust your span settings to wherever you need it set to as well, as you can see here. The bandwidth settings can also be adjusted here as well, and your amplitude adjustments if you need to make any adjustments. If you wish to do adjacent channel power, You can do ACPR measurements here, and everything will pop up accordingly with the information on display here. As you can see, the left and right ACPR readouts. Reference channel bandwidth can be adjusted. I have it set for 10 megahertz since we're looking at a 10 megahertz signal. If you wish to measure your CCDF, you can do that as well and get instant CCDF measurements. Another feature of the VST is the RFMX waveform creator and the RFMX soft front panel, as you see here. Either way, if you go with RFMX or with your standard RFSG, RFSA soft front panels, you can achieve various types of signal creations and measurements using either one. In here, I loaded a 5G NR signal, standard 256 QAM, and into here, where you just simply go to add. You can also add carrier definitions. Go to File and go to Open. You will have various standard 5G NR waveforms if you do get the 5G NR package from us for the NIVST. You simply select one, load it, and everything will load up here with all the information needed for it, such as its carrier definitions. You can go here to Graphics, Regenerate Plot, which will generate the R file and show you the plot as you see here. From here, you can also adjust the scale to however you wish. Your frequency control, access controls, markers. Here, in this case, we're doing a simple FFT measurement. You can also do IQ versus time, power versus time, CCDF here as well, and so on. If you wish to save the file, you can save the file as well.
For more information on the NIVST or any of our products, please contact your local Electrorent sales rep or visit us at electrorent.com. Don't forget, hit that subscribe button to follow us. Thanks for visiting Tech Talk with ER.